Hello, so Michael here again, and today I'm going to talk about programming in C, of course, and we're going to talk about structures, struct, and linked list, and we're also going to talk about some pointers to struct, dynamic memories, and equal, but it's basically around structs. So here we have the agenda, and it's from chapter 16, structures, in our book C, programming language. So we're going to start with the basic struct keyword to create new variables. We're going to see how we can use them, copy them, pass by function by value, initialize them, how we can change its value, and we're going to see how we can work with arrays of structures. We're going to see how pointers to structures work. We're going to see how we can build up more advanced data structures like linked lists using these structures. Then we're going to wrap it up by seeing how Typedef struct can make these structs look a bit more nicer in our code, create our own types. We're going to see about the union construct and bit fields. And this is all a bit more how to work with on the bit level, but it's basically the same structure as a struct. We also, during this lesson, we're also going to talk a bit about how to work with dynamic memory allocation when we sort of allocate new memory to pointers. So let's start with the structure. So struct in C it's generally a collection of one or more variables, could be of different types, and it's a way to organize complex data structures. We are sort of grouping the related variables, and we want to treat them as one unit. And these structures, we can copy them, assign them, initialize them, and pass them to functions. So let's see how this is done. I'm going to start with the struct person here. So if we consider a person and we just say, okay, person got a surname and a last name and it got an age. So we got three properties, variables we need to sort of represent the person. And then we want to be able to print the person. So we create a struct person with these three variables in it. And we create a function that is taking a struct person as a parameter, and it should then print it. So here I'm gonna have some example program just to see how it actually works. So I'm creating two persons up there. So I'm creating a struct person mouse and one doe. And the first one there I'm gonna do initializing for. So you see the curly brace we have up there, and then we have the surname, the last name, and the age in that order. The struct person doe is not initialized, but I'm sort of assigning its individual values down there with the surname, last name, and the age. And then I'm going to print both persons down there. And the print person looks a bit like this. So we're going to print a person. The struct person comes in as a parameter into this function, and then I'm just going to print it as a string, and a integer. And I'm using here, you can see I'm using the dot notation. So it's the struct, dot, and the part of the struct. So a person dot surname there. And we're just printing the two persons out there. This is an example of how we can copy a struct. So I'm creating the first structure there at the same time. I'm initializing that, and then I'm creating another one, struct person kinna, and I'm assigning that. So I'm taking a copy of the moose struct person and assigning that to kinna. And then I'm going to change only two. I'm going to change the surname and I'm going to change the age. And then I'm going to print them out, and we see here at the bottom then. So Mikael rows 42 and we have Kinna rows 39 instead. Just showing how a copy of a struct is done. So let's see how we can work with this pause to functions so we can understand it. So I'm gonna try to make an update person function. So I'm gonna send in the struct person, and then I'm gonna try to change the struct and see if it's done. So I'm gonna do it in 3 different ways here. So I'm going to do it pass by value, and then I'm going to do a pass by value and return the struct, and then I'm going to do pass by address. So let's see how these are sort of actually can change or not. So this is the first one. Here I'm going to pass by value. So the struct is copied into this function, and I am trying to change it here, but these changes will not be visible outside of this function because this is just a copy of the struct, so I can't change it. So if I'm going to sort of showing how I'm working with this. So I'm creating the struct person mouse up there, and then I'm going to print the person, then I'm going to update it by value, and then I'm going to print it, and it's going to be the same person here, despite that the update person value tried to change it. So here's just sort of it's a read only pass by value, if you would say like that. So if I want to change it, I could do it like I do pass by address, and this pass by address that works with any type in C. So I'm just using the same concept here. So I'm taking now a struct person pointer instead. So this function should take a pointer to the object it's going to change. And I'm just showing you 2 different implementations. I'm using the arrow notation up there, and here is just another way to do the same thing. I'm doing the sort of pointing at the I need to wrap it in parentheses and a star a person, and that just to find the actual sort of pointer and that what it points to. So this dot notation, or this one here, is basically doing the same thing. But this time, since I'm doing this passing by address, and here is how I'm going to use this. You see this update person pointer here is now sending in the address of the struct, and the changes that is done within the function will be kept after also. So here we see that I print out one person, then I do an update and I print it out, so it has changed its value. So yeah, let's see at another one, another example on how we could sort of implement this update my structure function. So here we're going to do a struct person, a person, so it's going to be copied by value. I'm going to change its value here, and then I'm going to return the struct. I'm going to return it by its value. So it's basically a copy of the changed structure in the function. And I'm going to return that. So I'm returning a struct person here. And this is also a way to sort of implement function that can actually change its value and make that changed value available to the caller of it. So I'm going to use it again here. Update person return. I'm just going to send in the struct person as a pass by value here. But I'm also assigning it to the returned value. I'm going to assign that. And here again, then I'm getting this the details on the person, the original person, and then the updated person. So it's 3 different ways on how to work with structs in respect of the sending it as a parameter to a function. So let's sum this up. We have structs. This is basically a way to gather a lot of variables under one name and one structure. We can initialize, assign, copy them. We can send them as parameter to functions, either by value or pointer. We can return a whole struct. So that is basically all the ways we need to be able to sort of work with this struct. Let's see how we can work with arrays of structures. So through the rest of the presentation, I'm trying to build a small game here. And so this is my small game, how it looks like. I'm going to work with a struct point here. And my struct point has a position X, position Y, and a character value. And this is the first here. I'm going to create an array of these structs. So struct point game array. So I'm going to have a game array containing all the parts of the game. And to start here, I only show you how can I initialize an array when it contains structures. So I can use the curly braces here. So I'm wrapping the whole array in curly braces, and each item I also wrap in curly braces. So that is initializing an array with all the struct elements. So I'm starting to build a game here. So it looks a bit like a game of noughts and crosses, or Luftwache as I call it in Swedish. So I'm having this struct point where I'm actually going to place an X or an 0, X or 0, and it's going to have a position in the game board, and I'm going to work with a game board that is five columns and 5 rows. So my whole game size here will be sort of up to 25 places where I can put the cross or the sort of 0. I'm going to have a print game function that can print out the whole game, and that is going to take the whole game array of struct points array then as the parameter into it, just to print it out. And this is a way sort of just showing you how I can individually assign a struct to each part of the array. So I'm having a sort of array here. So I'm having game 0, game 1, game 2. So it's the position, well, each move. Let's go with the move or placement of the cross or the 0. So game 0, I'm going to assign it with a struct point, and then it's a cross. I'm going to put it on position 1.1. And here I need to sort of typecast this with the curly braces initialization. I'm going to typecast it to a struct point, so the actual type there, the compiler can see that the actual type I'm creating there is mapping to the type that the array is having. Then at the bottom there, just print the whole game by just sending the complete array to that function. And this is just how the game could look like when I print out these values here. So we have 5 columns and we have 5 rows. And if you want to sort of look more on how this is actually working, you can see some of the example programs, and this example program is a struct array, it's called. So that was array of structs, and yes, we need to know the amount of structs to be stored. So we need to have the size of the array here. So in this case it was 25 positions, so that is how large the array will be. And sometimes this is okay to define a data structure like this all at once. And even if I only have 1 move or 2 move or 3 placements positions there, I'm only using 3 out of 25. Well, sometimes it's okay. Sometimes you need to have a bit more better memory management and not overuse the memory. So let's see on how this could be done, and let's start looking at how can we work with pointers to structures here. So this is how can we add more entries dynamically, so we don't sort of allocate all the memory for the whole game plan as one. So we want to do that without predefining all the structures. We want to sort of allocate memory when we need it. So let's see how we can do this with pointers. I want to do the game a bit like this. So I'm going to place my move, and then I'm going to put up, I'm going to put a X at position 3.3, and then I'm going to print the game. Then I'm going to put another move, so I'm going to put the ring at 5.5, and then I'm going to print the game, and so it moves on. So then I want to sort of create the new entries when I have when the player has entered them. So let's see how this can be. So first we need sort of the basic structure then, and here I'm going to change the array to now contains a struct pointer. So struct point star or struct point pointer. So the game array, and this is still an array for now, will just now contains pointers to struct point. So it's a small improvement than containing the struct point. It now only contains a pointer to a struct point. So in this game, I need to change the print game function. So it will now take a game array with struct point pointers. And I'm going to create the whole game array there. It's still allocating in game size. It's fine. I'm going to keep a bit of track on how many number I have sort of taken, just to see that I don't sort of put in more numbers than the game size is. And then I'm going to do a thing here. I'm going to unset the memory. So I'm going to memset the game array, and I'm going to set it to 0. And the size of game, that will help me show the compiler, okay, how many bytes do you want to sort of reset? Well, I'm going to resize size of game. So that is a way to say how many bytes is this particular variable sort of creating or have allocated. This is just initiating a memory area to the value of 0 in this particular case then. Sometimes that is important, and sometimes perhaps you don't care about if the memory is initialized, but this is a good way sort of to take control of the memory area and really initialize it. So like we see, memset, set the memory area to a specific value, and size of help me decide how many bytes my variables are sort of holding. Yes. So let's prepare to read in the content into sort of each move into the game board, or place it as I have called it here. So I'm going to do this in a loop, and I'm going to do this until the game board is filled. And for sort of each loop, I'm going to create another struct point star. So I'm going to call that place it, and then I'm going to create some temporary variables that I can just sort of read in the values into first. So just a bit of printf, then I'm going to scanf into these temporary variables, and then I'm doing a fix here. So I'm clearing the standard in. That is just because sometimes when I'm doing a lot of scanf in a loop, this \n, the new line character, is still available on the next line when I'm sort of reading it again, and I want to clear the standard in. So this is just a way to this dirty while loop here, is just to clear the standard in and be able to sort of use scanf in a loop like I'm doing here. So when we have this sort of the temporary variables, we have scanf them, then we are creating the new move, or place it as I call it here. So I'm going to create the memory for it on the heap using malloc, and I'm going to allocate that much byte that represents the size of my struct point. So size of struct point will turn out to be this many bytes that I need for that type of data type, and malloc will sort of create the memory on the heap needed. And place it will hold a pointer to that memory, so I can write to it. And then I just start writing to it. I add the value, the position X, the position Y, giving it the value, and when it's done, I'm going to take the place it, and I'm going to enter it into the game array. And when I do that, I also increment number taken, just to have a sort of control over how many items have I put into this sort of game array for now. And when this is done, I can just send the whole array to the print game function, and it will be printed. So let's see what we did here. So we changed the game array. It is still 25 positions, as big as the board is, but we changed it a bit to contain struct pointers instead of struct points. So we're not pre-allocating the same amount of memory that we did before. We also showed you how we could use memset to set a memory area, and we are setting it to the byte 0, so we're initializing, like say, and we're using the size of operator to let us know how large is this this array actually. We saw how we used struct point star, call it place it. So each new draw was created by a new malloc that allocated the size of a struct point to it, and then we just added it to the game array. So we have a malloc memset size of, and we should also mention the free function here. This is used to deallocate or free up the memory that we have previously allocated with malloc. So all the memory that we are allocating on the heap should also be freed up. There is no automatic garbage collection in C that does that for us. So we need to do free of the memory. Okay, when the program shuts down, every memory is freed that was sort of allocated in the program. So that's why I'm not using it here in my small example program. But it is good programming manner to always free up the memory that you have allocated by malloc. Remember that. So now we have this struct pointer. So pointers to struct point in the game array, but it's still 25 sizes long. So we're still allocating this array for all the positions in the game. Can we do this more dynamic? Can we allocate sort of all the memory when we actually need it? So let's see what self-referential structures can do for us. And this is a nice name for what you might have heard about linked list and other related data structures, tree structures and so. So about self-referential structures, I'm going to do one, and this is basically about structs referencing other structs. And I'm going to show you an example here by doing a linked list. And this small single linked list is basically put up like this. So it is a struct that contains data and a pointer. And the data can be any type of data. And the pointer will point to the next element in the list and the next element in the list, and finally it will be pointed to 0, and then I know that the list is sort of ended. And this is the basic structure of this linked list that I'm going to create now. So what am I going to need in my program to actually carry this out? So I need one pointer to the start of the list. It's actually a pointer to the first element of the list. So this linked list is an element put up in a sort of a chain of elements. The last element points to 0, that's the end of the list. So I'm going to create here a struct element. So struct element, and I'm going to call it a linked list. That's going to point eventually to the first element in my list. And then I'm creating a struct element here. So this is a basic how each element in a linked list could look like. It's going to contain data. And here I'm just creating the struct data pointer. So it can be any type of data there, basically. and then I'm going to create sort of the struct element pointer, and this is going to point to the next element in the list. So if I'm going to use my game and update it to be a linked list instead, I could do it like this. So I'm still keeping my struct point up there. So it has share value, pos x, pos y, as it did before. Then I'm going to add a struct element. And this element will then contain data as a struct point star. Okay? And then it's going to contain a struct element next. So this is the next pointer. I need to update my print game here. So it's going to take the list now. And the list is actually sort of pointing at the first element, so my list is basically a struct element pointer there. We can also see here, down here, I'm creating my whole linked list, and it's going to be a struct element pointer, so this linked list, and I'm going to initiate it to 0. The linked list is empty to start with. Could I actually have chosen another type of structure for this? Yes, for sure I could do that. So if you look at the struct element that contains the struct point star data, yeah, I could basically take the whole struct point and just place it into the element. That could be fine. I could do it like that. I could also do it the another way around. I could take the in the struct point up there, I could just add a next pointer. So struct point star next. I could add that, and then I could just have a linked list of struct points. But just for the sake of this example, I selected to use the struct element here just to show off how sort of a generic way of building a linked list, how it looks like with a next pointer and a data part. Okay, so let's see. Let's move on how we're going to sort of create our first element. So the player is going to do the first move here. And we're going to create the first element there. So I'm preparing the first element. So I'm going to create the struct element star new element, and I'm going to allocate the memory for it, as much byte as needed for the struct element. And then I'm going to set the element next pointer to 0. So this is now it is not the last element in the list, because this is only a element. It is not contained in a list for now. I'm just preparing it to adding it to the list here. So when I am having that set up, I could creating the allocating the memory for the data part. So I'm allocating memory up for a struct point there. And then I'm done with that. So then I can assign the point. So I'm taking the new element data, I'm adding value, pos x, pos y, whatever the user sort of have entered there. So now I have the new element with its data and next pointer set up to 0. So then I'm going to add it to the list. So I have chosen a way here where I insert the element at the beginning of the list. So let's see how that looks like. So the first time when the linked list is 0, then it will not go into this if statement there. So it's only going to do linked list is equal to the new element. So that is the first time when the linked list is empty. It's going to point to the first element that has its next pointer set to 0. Good. For all the other places, all the other times when we're inserting the element 2, element 3, and element 4, and so on, the if statement there is going to be true, and it will be sort of that the new element's next pointer should now point to the linked list. Okay, and the linked list will now point to the new element. So this is basically creating a structure that each new element is put, you can figure it, in the front of the list. And all the other elements in the list is getting at the end of the list. So the first element will always be last in the list, and then the most recent element will be first in the list. And this is a way of sort of implementation detail, how I choose to do it. I choose to do this because it gave me very, very little code, but I could also sort of choose another way to work with the data structure, that I sort of I add it to the end of the list, or maybe I want to have a sorted list. So when I insert the new item into the list, I keep the list sorted. So this is implementation details. But anyway, I'm having this linked list, and when I'm going to print the game, I'm just going to print it and send the whole linked list to the print game function. And let's see a part of this print game function that I'm using here. So it's going to take the sort of game pointer here as the parameter. And then I'm going to show you how I'm traversing the list. I am walking through the list here. And why do I do this? Well, basically it's just, for me, it was an easier way to print out the whole game plan when I sort of converted my existing game data structures to a two-dimensional array, because it made it easier to print the game in this small example program. So then I want to sort of go through the whole list. So I'm going to do it like this. I'm going to do a while loop, and I'm going to use game as a sort of a pointer for each element, and I'm going to move the pointer for each element to the next element, to the next, and at the final element this will be 0, and then while loop will be sort of skipped. So this matrix here, that is just sort of for converting my data structure linked list into a two-dimensional array just for printing. But we see here while game and game equals game next. These are the two essential parts that are all basically traversing the whole sort of game list. And you might figure that hey, Michael, you're gonna lose your list pointer at this point. Yeah, I know, I'm gonna lose it, and sort of game pointer here will point at the last element in the list, or even point at the 0 at the end, but it doesn't care here. So I'm not going to use the game variable in the code anymore here, so it's fine to do it like this in this case. So let's see, we have a linked list. We have a list that points to the first element, or 0 when the list is empty. Then we have these elements, and the next there points to the next element in the list, or 0 when there is at the end of the list, so it's no more element there. An element data can be a pointer to another struct, or just include the actual data into the element struct, however you feel sort of suits you need at the particular time you're doing this. So we can create a lot of different types of data structures with this sort of basic construct, where a struct is referencing another struct. We could create a double linked list there, and then we would have element next, and we would also have element previous. And that would have the advantage that it's easier to traverse that double linked list in both ways. We could perhaps create a circular list where the end of the list is pointing to the beginning of the list. So we could sort of traverse sort of a circle list around. We could kind of binary tree, a tree structure. Perhaps I would call them node left and node right when I was working with that kind of data structures. And these data structures, they could be sort of sorted when I do insert and deletions, or I create just a sort of another function that is sorting my linked list or my binary trees. Okay, fine. So what we have seen here is sort of a embryo, a start to build more complex data structures using structs and pointers to structs. Let's see what Typedef can do for us. It perhaps makes our code a bit more easy to read. So here we have this Typedef struct point, it's the same struct point I'm using here. So struct point, I'm just putting Typedef in front of it, and at the end of it, I'm naming it point with a capital P here. So then I can use that new type, and I'm using it here when I'm creating the struct element. So I'm creating data is now a point pointer. I'm also using Typedef for the struct element there. I'm labeling element with capital E. And then I'm gonna, when I'm printing the game down here, I'm just using the type element instead. So I'm sending an element pointer, which is basically the linked list I was using. So Typedef is just a way to label my own types, and that could be useful for readability in my code, for example. Unions is a bit like the structure. It can contain the same things as the struct, but it can only hold one value at a time. So here I'm having a union data, and this can only hold a char, a int, a float at one time. And so I can assign all three of them, but it will be the latest assigned that is actually keeping its value there. So union is allocating memory for this data structure, and it's allocating the most bytes needed. So that many bytes for the largest data type, that many bytes is sort of allocated for it, but it can only hold one value at a time. So I'm just going to show it off how it works here. So I'm going to take in union data, so I'm creating data as a union there from the data, and then I'm going to just assign the value a char. So you see here I'm using the struct notation for the parts. So I'm going to assign x, I'm going to print it, then I'm assigning int there, 42, and I'm going to print it, then I'm assigning a float, and I'm going to print it. So it's going to print out the right values here. But it is the programmer's responsibility, you and me, to keep track on the latest value used, and so we need to be knowing what's in the union. So unions can be used in sort of specific ways, but perhaps some say we use it to convert values between float and integer. So we have a union containing one integer and one float, and we just assign the value to it, and then we can sort of read either the float value or the integer value. We could use these unions to sort of create a bit of sort of typed values, so it can contain different types at different times, and we can sort of create this. And this, when we do this, we use a struct together with a union to sort of keep track on what is the current value in the union. We can use it for low-level bit access, so we can use it together with bytes, and bytes in perhaps in the union, and we can add a struct. So it is we're not going to see how it's done, but it's just examples on one way of efficient low-level usage where unions can come into place. So still, the basic construct of unions is you can add up as many data types or variables as you wish, but it will only allocate memory for the largest one, and it can only hold one value at a time. Good. We're gonna stay here on the bit side of C, and we're gonna see what the bit fields can do for us. Bit fields is also a way of structs, and we're gonna see how that works with only bit manipulation. But before that, we're gonna see how we can use enum flags and work with bits. So I'm gonna create here. This is a sort of a keeping track on the health of a car. So I'm going to create an enum variable here that has brake pad condition, brake fluid level, engine temp, and each of these are 1 bit large. And so this is one common way of working with bit in a more sort of, you show off what the bits are actually looking like. So we call this enum flags. And enum flags, when we work with them, we're using bit manipulation and logical operators to make it work. So this is code for how it could look like. So we're going to set the bits here in the car. So we're going to set 1 bit, or we're going to set 2 bits at the same time. We can use this construct here to do unsetting of the bits, 1 bit, or unset 2 bits. And we can sort of test the bits, how they are. And this is an if statement that show that it will be evaluated true if both bits are off. So this is enum flags and how we can work with bit operators through the bit logical operators. So let's have that in our mind and see how bit fields can do the same but show us a bit different code. So bit fields are data structure for bits. So we can create a structure for all the bits and then make up the word. We can access the bits as members of a struct. We can set, unset, and test them directly. And there's no need for this bitwise logical operators that I just showed you here with the enum flags. So here is the same thing then, but we set it up using the Typedef struct as a car. So it's a struct. I just Typedef it as a car for now. And then I label it as I did before, and I'm going to type them as unsigned int breakpad condition. And then we have this colon, and then I say how many bits should this value take up? And all these values take up 1 bit. And then I'm going to show you an example how I'm going to work with this bit field then. So I'm going to create the car up there, so it's going to keep the status. I can set each bit here. It looks like I'm setting them independently, so I'm setting breakpad condition and using the struct notation with a dot there. Or I'm setting 2 at the same time there. Core fluid level, core engine temp equal 1. I can unset the bit individually. I can test the bit. So this is, when you compare this to the enum flags, I guess you can say that you get a more readable code. It's more obvious what you are doing, even when you are not so skilled in sort of the logical operators for bit operations. But it's the same. This is bit fields. It's a way to work with structs and bits. So during the day we have used a lot of some functions to allocate memory. So let's review them before we stop here. The standard lib contains memory for allocate dynamic memory on the heap. We have used malloc, so we know that. Calloc is more or less the same, but it will allocate memory chunks in a row. So let's say if I have 3 structs I want to allocate memory for in a row, then I can use calloc that will allocate 1, 2, 3. So I just say how many items I want to be allocated, and then I give the size to it. Realloc will reallocate memory. So when I have a data block already allocated, and then I want to sort of make it larger, then I can do realloc on that memory. So I will have it sort of, the memory will be on the same place. I just gonna build it a bit larger. So then I'm gonna do realloc to it. We talked about free and the importance of freeing, deallocating the memory that we have previously allocated with malloc, realloc, calloc. And that is important. No thing as automatic garbage collection of this memory in C. We talked about the size of operators, so it returns the memory, the amount of bytes that is allocated to this specific data type that we're doing with the size of. We also saw how we could sort of set the part of a memory with a memset, and we just sort of putting a pointer to the block of memory with what type of value want we set it for, I set it to 0, and how many bytes are we going to set there. Okay, so let's sum it all up. We have talked a bit about structures today. Basically, the whole lesson were about structure. We initially saw we could sort of copy them, we could initialize them, we could pass them to functions by the value or by address if we want to change them, and we also saw how we can return a struct from a function. We saw how to work with arrays of structures. We saw how to create sort of pointers to structures. We saw how we could create more advanced data structures like linked lists when we sort of have structures pointing to another structures and so on. We saw how Typedef struct could make our code a bit easier. We saw the union. It's a struct, but it can only hold one value at a time. We talked about bit fields that we could use. It's a structs of bits and made it easier to work with bits like we are using the struct. Very sort of, well, the code shows how we are working with each individual bit, so it's really easy. And we talked a bit about the different functions that is then when we are working with dynamic memory allocation and freeing of memory. And basically that was what I had on my mind today. It's all about struct, how we could work with them, gather all the variables and focus on sort of the, when variables make sense to be bundled together, well, then we can use struct and send that around. And yeah, we talked about dynamic memory allocation also. So now we need to code to learn this. So I hope you do some homework and code, and I see you sometime again. Take care. Bye-bye.